Hello there, this is Jude Socrates. Welcome to today's video where we will talk limits at infinity and infinite limits. Now, in basic calculus, we have seen this concept. So we are going to apply some of the concepts that we learned there to study exponential functions and their limits at infinity, and more complicated functions which involve exponential functions. And we're going to see, can we figure out limits at infinity or minus infinity for these functions? Do they also have horizontal asymptotes or vertical asymptotes? So let's see what we're going to do in this video. So we will start by reviewing the basic concept of a limit at infinity by going back to power functions, x squared, x cubed, and so on, but also for negative exponents. Okay, so we'll take a look at 1 over x cubed, 1 over x squared, and so on. So whenever you're dealing with the concept of a limit at infinity, you are asking also about horizontal asymptotes. But while we're at it, let's also talk about vertical asymptotes. Okay, some of the power functions, those that involve a negative exponent, if you would recall, they have vertical asymptotes as well. So we're going to apply the lessons, the ideas that we see in these cases to look at limits involving exponential functions. All right, so we are going to start with these, 12 limit questions. Okay, so of course they're similar to each other. They are probably related to each other. And we will figure these out, not just using our heads, but also by looking at their pictures in GeoGebra. Okay, so let's start with exponents, which are positive. So let's take a look at x cubed and x to the 4. And let's ask, what is happening to x cubed as x is getting bigger and bigger, approaching positive infinity? How about at minus infinity, when we are plugging in a number which is large but negative in sign? Okay, large in absolute value but negative in sign. Okay, same question if you're dealing with a fourth power. What about x to the 4th? Now, what happens when the power is negative? Okay, so we will think about 1 over x cubed, in other words, x to the minus 3. And aside from asking, well, what happens as x is getting bigger and bigger, whether it's positive or negative, what happens also as x is approaching 0? Okay, so this time getting smaller and smaller, and we will approach 0 in from two different directions, from the right and from the left. Okay, so remember that that's what these symbols are about. Okay, they're not exponents. This says that we are approaching 0 from the positive direction and approaching 0 from the negative direction. Okay, and similarly for 1 over x to the 4th power. Okay, same questions. What happens as x is getting bigger and bigger, whether it's positive or negative values? What happens as x is getting smaller and smaller, close to 0, but using positive numbers and using negative numbers? Okay? All right, so shall we start thinking? Okay, let's look at these questions first. Okay, so we are plugging in a number very large, okay, like 1,000, 1,000,000, and then we're cubing that number. Okay, well, 1,000,000 cubed, gosh, how many? A million has 6 zeros. If you cube that, you're going to get, 18 zeros. So it's a lot bigger number. Okay, so it looks like the limit for x cubed as x goes to plus infinity is also plus infinity. Okay, how about as x goes to minus infinity? Okay, so negative 1,000,000. Think about negative 1,000,000 now. You cube it, well, you still get a large number, but this time because you're cubing negative 1,000,000, the sign stays negative, right? So therefore the limit for x cubed should be negative infinity as x also goes to minus infinity. Okay. Is x to the fourth going to give us the same answers? Okay, well, 1 million to the fourth power is also extremely large, so that will also go to plus infinity. But negative 1 million to the fourth power, now that's where the difference is. Okay, for the cubed, you multiply negative 1 million to itself, I guess 3 times. Negative times negative times negative is negative. But if you multiply negative 1 million to itself 4 times, then you will get positive infinity still. The sign will stay positive. Okay, so that is a slightly different answer from what we see above. Okay, so let us verify that these 4 limits are correct in GeoGebra. All right, here we are in GeoGebra. So let us input x to the third power, and that should look familiar. Okay, so as x gets bigger and bigger to the right, f of x, the y-coordinate, is also getting bigger and bigger. But as we go to the left this time, to minus infinity, x is getting, y is getting larger and larger, but with negative values. Okay, so it looks like our 2 limits are correct. Let's change the 3 now to a 4, and we're going to get a different graph. Okay, so as we mentioned, if you're multiplying to a number, let's just say it more precisely. When we're raising a number to a fourth power, we're multiplying 4 copies of a negative number, and because there are 4 of them, then the sign becomes positive. Okay, so as we can see here, it doesn't matter whether you plug in a positive number or a negative number, the y-coordinate is getting larger and larger. So both limits at plus or minus infinity are going to positive infinity. All right, so now let's think about 1 over x cubed, and we're looking at 4 limits. Okay, so as x is getting bigger and bigger, we're looking at 1 over x to the third power. Okay, so 1 million, you take the reciprocal, that's instead of having 6 zeros to the left of the decimal point, you have 6 zeros to the right of the decimal point, which makes it very, very small. And then you cube it. So instead of just 6 zeros, you're going to get 18 zeros. So that limit should be a 0. Okay. How about at negative infinity? Okay, so this time negative 1 million, but if you take the reciprocal, it's still going to have 6 zeros to the right of the decimal point, but this time it's negative. Okay, so it is still going to get closer and closer to 0. Okay, now a different kind of question. Let's approach 0 from the right. Okay, so let's think about 0.01, 0.001, and so on. When you take the reciprocal, okay, let's think about 0.01. 1 over 0.01 is 100. Okay, and then we're cubing that. So that's going to become a larger number. Okay, so it looks like the limit as you approach 0 positively is going to be positive infinity. Okay, how about a negative number? Okay, so again, you're multiplying 3 negative numbers, so you get a negative number as your answer, but the reciprocal of a small number, again, is going to be large. Okay, so putting that together, this time our limit is going to be negative infinity. Okay, so the limit coming from the right of 0 is different coming from the left of 0. From the right, it's positive infinity. From the left, it's negative infinity. Okay, something to remember. How about if you have an even power, 1 over x to the power 4? Okay, so same idea, reciprocal of a large number is going to be very small. You raise it to the 4th power, it's going to get even smaller. Okay, and it doesn't matter if you input a positive number or a negative number, we saw that the sign is still going to be positive. Okay, so either way, our limit is going to be 0 for plus infinity or minus infinity for 1 over x to the power 4. Okay, So how about as x approaches 0 from the right or from the left? Okay, so once again, you're multiplying four negative numbers together, so the answer is going to be positive. You're plugging in a number very, very small, like 0.01, but you're taking the reciprocal, and then you're raising it to the fourth power. Okay, so 1 over 0.01, 100 to the fourth power, we got 8 zeros. Okay, so that's going to be a large number, and we get positive answers for both of them. So the limit for these two are both going to be positive infinity. Okay, so let's go back to GeoGebra and see if our answers are correct. Okay, so let me scoot out of the way there. We have 1 over x cubed this time and 1 over x to the fourth. Okay, so let's put 1 over x cubed here, and we'll delete this. There we go. Ooh, so a very different kind of graph. Okay, so right over here, we can already see that our answers are correct as x approaches 0 from the right and from the left. Okay, so from the right, we are getting very, very large positive numbers, but coming from the left, we are getting very, very large negative numbers. Okay, so we're going to get a limit of plus infinity from the right and minus infinity from the left. Okay, now as x gets bigger and bigger as we go further to the right, as you can see, the graph is pretty much hugging the x-axis. Okay, even if you zoom in, yeah, you can hardly tell it apart from the x-axis. So that tells us that our limit is 0 as x is approaching plus infinity, and as we approach minus infinity, as x approaches minus infinity, you're also getting closer and closer to the x-axis, which means that our limit is 0. Okay, so let's change that 3 now into a 4. And ooh, okay, so something a little bit different happens. Well, as x goes to minus infinity and plus infinity, same behavior actually. Our y-coordinate is getting closer and closer to 0, but as x approaches 0 from the right or from the left, this time our y-coordinates are getting bigger and bigger on both sides. Okay, so we're approaching positive infinity, whether x is approaching 0 from the right or from the left. All right, so now that we have the basic idea, we are going to crank it up quite a bit and take a look at the much more complicated problem. Okay, we want to find the limit as x goes to positive infinity of 4x squared plus 4x minus 35 over 6x squared minus 7x minus 20. Okay, and after we do that, well, we're going to ask how about as x approaches minus infinity? Okay, do we get the same limit or something completely different? Does this function over here have a vertical asymptote? Okay, so just like we saw for 1 over x cubed and 1 over x to the fourth, we get a vertical asymptote as x approaches 0 from the right or from the left. So x equals 0 is our vertical asymptote. We will verify the answers that we get in GeoGebra. Do we really get horizontal and vertical asymptotes? Okay. So here's the problem. X is getting bigger and bigger to positive infinity. Okay. So we saw that when you have a power of x, that's also getting bigger. But you have also powers of x down here. So we have what are called dueling infinities. Okay. The numerator is getting bigger and bigger, but the denominator is also getting bigger and bigger. Okay. So in calculus, we say that this limit form is what's called an infinity over infinity limit form. Okay. So what are we going to do? Okay. So the basic idea is to think about our examples involving 1 over x cubed, 1 over x to the fourth. Okay. We said that as x goes to plus infinity, both functions, and from both directions, plus infinity or minus infinity, they both get very, very small. close to 0. Okay, so what we're going to do is we're going to be very clever. We are going to multiply and divide the function by the highest power, which is x squared. We will turn it into 1 over x squared. Okay, multiply by 1 over x squared and divide by 1 over x squared. Okay, so this put together is simply 1. We have not changed the problem. Okay, we are multiplying by 1. When you multiply by 1, the expression doesn't change. Okay, however, what we're going to do is we are going to distribute 1 over x squared to the numerator and this 1 over x squared to the denominator. Okay, so basically we are going to divide these three terms by x squared. Okay, so what does that mean? For 4x squared, the x squared completely goes away. For 4x, you get 4 over x squared. I'm sorry, just 4 over x. Okay, for minus 35, we get minus 35 over x squared. Okay, so x squared over x squared goes away completely, except for the 4, of course. 4x over x squared, you get 1 over x, minus 35 divided by x squared. Okay, repeat for the denominator. Okay, so x squared completely goes away. Minus 7x becomes minus 7 over x, and minus 20 becomes minus 20 over x squared. Okay, so this is good because we saw that 1 over x cubed, 1 over x to the fourth, they go to 0. Same, of course, with 1 over x and 1 over x squared. Okay, so the limit of these will simply be, we're now ready to get the limit, we will get just 4 plus 0 minus 0 and 6 minus, divided by 6 minus 0 minus 0. Oh, okay. So that's just 4 divided by 6, or simply 2/3. Okay, so that's our answer. We think, and we will check in GeoGebra, that this limit is simply 2/3. Okay, what about minus infinity? The follow-up question, how about negative infinity? And does this have a vertical asymptote? Okay, well, let's see what happens. If this were a minus infinity, this step is just algebra. This step is just algebra. This was the step where we made x larger and larger positively. Okay, but we were looking at 1 over x and 1 over x squared. So if this were minus infinity, it wouldn't matter, okay, because 1 over x and 1 over x squared still go to 0 as x goes to negative infinity. They get smaller and smaller. So the limit is going to be negative 2/3 as well. Okay, so that limit, we can now answer the question, should be 2/3 as well. Now, last question, does the function have a vertical asymptote and where? Okay, so we got vertical asymptotes for 1 over x to the fourth and 1 over x cubed because x is approaching 0, the denominator is getting smaller and smaller, which means that the function, the reciprocal, is getting bigger and bigger. Okay, so we can ask, well, when is this getting smaller and smaller? When is it approaching 0? Okay, so back to algebra then. Let's do it over here. That is our last question for this example anyway. When is this equal to 0? Is that possible? Okay, well, let's try to factor or use the quadratic formula. Okay, I'm going to take a risk and maybe one of them will have 2x, one of them will have 3x. Okay, after all, it is possible that we have 6x in one and x in the other. Okay, so let's see, I want negative 20 to be the product of the constants, and then I want minus 7 in the cross term. Okay, So let's see, lots of ways to factor minus 20. Okay, so how about trial and error? Minus 5 and 4. Let's see. Yes, I feel lucky. 2x minus 5. Negative 15 plus 8. Yep, that is negative 7. Okay, and of course we're dealing with Maple over here. So Madame Maple or Monsieur Maple, not sure. Definitely French. French Canadian. Let's compute factor. Aha, 3x plus 4 times 2x minus 5. Okay, so our candidates are negative 4/3 and 5/2. Okay, so the denominator is 0. Is 0 when x is minus 4/3 or x equals 5/2. Okay, and you might say, woohoo, we found our vertical asymptotes because we're dividing by 0. Not so fast. What about the numerator? What happens if we plug in negative 4/3 or positive 5/2 into the numerator? Okay, so let's make a copy here. But wait. What is the value of the numerator at these 2 points? Okay, so for the first one, we have 4 times negative 4/3 squared plus 4 times negative 4/3 and minus 35. Okay, so that's what we get for minus 4/3. And what do we get? Negative 299 over 9. Okay, so that's good. The numerator is not 0. It's a negative number. We're dividing by 0. Okay, so it looks like minus 4/3 is a vertical asymptote. But what about 5/2? Okay, so this time we will take minus 5/2 and we will crank out what we get. Positive 5/2 here, squared, positive 5/2 minus 35, and what do we get? We get, 0. So what does that mean? Both the numerator and denominator are 0 at x to the 5/2. Okay? So that means that this numerator can actually be factored so that we get 2x minus 5 as well as one of the factors. Not quite obvious just by looking at the question. Was it? Okay, what is the missing factor? It is 2x. Okay, now we get both 2x's. And you want minus 35, so it looks like we need a plus 7. Okay, so is that right? 7 times 14 minus 10, we get positive 4. Okay, so the numerator is also 0 at 5/2, which means that the limit as x approaches 5/2 is not going to be infinity or minus infinity. Okay, so let's take a look. Let's check it out. Okay, so we have everything we have now. Yes, well, let's do it over here. Okay, what is the limit as x approaches 5/2? Okay, is it going to be plus infinity or minus infinity or something else? Okay, so we said that the numerator factors as 2x minus 5 times 2x plus 7. And we already know that the denominator factors as 3x plus 4 times 2x minus 5. Okay, but we are taking a limit, so we are not exactly allowed to plug in 5/2 exactly, which means that these two expressions, both of which are 2x minus 5, they're not 0. They're close to 0, but they're not 0. So we are still allowed to cancel them because we're not canceling out zeros. Okay, so there we go. Those two can go away. Aha! But now, neither the denominator is not 0 anymore. So according to basic calculus, when you're dealing with a rational function and the denominator is not 0, you can apply direct substitution. So the limit is simply this expression, this function, when we plug in 5/2 for x. Okay, so we have this, and we just have to clean it up now. We get 12 in the numerator, and we get 15 over 2. 4 becomes 8. 8 plus 15 is 23 divided by 2. Okay, so that simplifies to 24 over 23. Ooh, just about almost equal to 1. Okay, so we get bonus information. We weren't being asked what is going on with this other number where we get 0 in the denominator. Okay? The limit is not infinity or negative infinity. It's 4/3. Okay, so let's check it out, what's going on with this function in GeoGebra. Okay, so our function is 4x squared plus 4x minus 35 divided by 6x squared minus 7x minus 20. Ooh, okay, there it is. All right, and we said that our limits at infinity or minus infinity were 2/3. So we have a horizontal asymptote y equals 2/3. Ooh, check it out. There it is. As we go further and further to the right, the graph is getting closer and closer to y equals 2/3. And the same thing to the left. Y is getting closer and closer to 2/3. Okay, and what did we say? There's only one vertical asymptote. Okay, and that was at x equals minus 4/3. So let's check that. X equals minus 4/3. Ooh, there it is. Okay, so it kind of looks like what we saw for 1 over x cubed. Okay, where as we approached 0 from the right, we went to plus infinity, and from the left we went to minus infinity. So this time we're approaching negative 4/3 from the right and from the left. Okay, I wasn't asking in the problem which infinity are you approaching. I was just asking, do you get a vertical asymptote or not? Where are your vertical asymptotes? Okay, so the other value that we got, we did not yield a vertical asymptote because both the numerator and the denominator were 0. And so our limit was not plus or minus infinity, but rather it was something like 24 over 23. Okay, so we do not have any other vertical asymptote in our graph. All right, so after that review, we can now get straight to our main course, which is, well, what happens to exponential functions, and whether it's the natural exponential function or general exponential functions as we approach plus or minus infinity. Okay, so this time the behavior is quite different at each kind of infinity. Okay, so we saw that e to the x is an increasing function, but e to the negative x, e to the minus 2x, will be a decreasing function. Okay, and as an increasing function, as we approach positive infinity for x, the y also approaches positive infinity. Okay, so for e to the positive 3x, the limit as x approaches infinity is also plus infinity. But as you approach minus infinity, your limit is going to be 0. We have a horizontal asymptote as e to the 3x goes further and further to the left. It is backwards for e to the minus 4x. Okay, we have a decreasing function. So at plus infinity, your limit is 0. But at minus infinity, your limit is going to be plus infinity. Okay, so now for these general exponential functions, and I deliberately gave you two bases which are reciprocals of each other. One of them is 3/2. Its reciprocal is 2/3. Okay? So what makes them different from each other? Well, 3/2 is bigger than 1, but 2/3 is smaller than 1. Okay? So recall that when the base is bigger than 1, you have an increasing function because ln of 3/2 is a positive number. So you get e to the ln of 3/2 times x, which has a positive coefficient, just like our 3x over here. Okay? So the pattern will be similar to e to the 3x. At infinity, you are going to get infinity also. But at minus infinity, you are going to get 0. Okay? 2/3 to the x is the reverse because ln of 2/3 this time is negative. Okay? So the coefficient of e in e to the ln of 2/3 x is going to be negative. It will behave like our e to the minus 4x over here. Okay? So at plus infinity, your limit will be 0. And at minus infinity, our limit is going to be plus infinity. Okay? So let's take a look at these 4 functions in GeoGebra. All right, so we have e to the 3x to the 3x. Okay, there we go. So as promised, it is an increasing function. So as x goes to plus infinity, y also goes to plus infinity. And as x goes to minus infinity, we have a horizontal asymptote, the x-axis, so y goes to 0. If instead of 3x, we had negative 4x, watch, 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 boom, it flips around. Okay, so this time, as x goes to plus infinity, your y goes to 0. And as x goes to minus infinity, your y goes to plus infinity. Okay, so now we input our general exponential functions. 3/2 to the x. Ooh, okay, so that should remind us a little bit of e to the 3x with a positive coefficient. So as x goes to plus infinity, our y goes to plus infinity also. As x goes to minus infinity, our y goes to 0. We have a horizontal asymptote as well. Okay, and remember that's because our general exponential functions come from e to the x. They look like e to the something x, e to the ln of 3/2 times x. So if we flip this, the function is also going to flip. Okay, so watch. Boom. Okay, just turned around. And this time, as x goes to plus infinity, your y gets close to 0. As x goes to minus infinity, your y goes to plus infinity. All right, our last example. We are going to look for this limit as x goes to plus infinity. So before they were quadratic, this time we have exponentials, okay? 2 kinds of exponential functions. Okay, so we want the limit as x approaches plus infinity. What are we going to do? Well, remember the idea last time. We multiplied and divided by 1 over x squared, right? So, well, we have 2 candidates now. Should we multiply and divide by 1 over e to the 3x or 1 over e to the negative 4x? Okay, well, you know what? How about we try both? Okay, let's see which one is going to work. Because after all, there's a follow-up question. What happens as x goes to minus infinity? Okay, so maybe one of them will work at plus infinity and the other for minus infinity. Okay, so let's check. Okay, so we will also do that over here. Multiply and divide by 1 over e to the 3x. and 1 over e to the 3x. Okay, so this time we need to remember our rules for exponentials. Okay, so we're basically dividing by e to the 3x. So e to the 3x over e to the 3x, gone, gone, gone. Okay, and the same in the denominator. Okay, but what about e to the minus 4x divided by e to the 3x? Okay, so yeah, you know what, let's do that. Let us take this, and I'm going to grab that, and let's put it inside. Okay, so we'll get e to the minus 4x over e to the 3x. Okay, and the same thing over here. So actually, I can just copy that whole thing down here. Okay, so we have effectively distributed 1 over e to the 3x to both the numerator and the denominator. Okay, so I hope you remember your rules for e to the u over e to the v. Okay, so that was in that video where we first learned about the properties of exponential functions. So we have e to the u over e to the v is e to the u minus v. Okay, so this becomes e to the minus 4x minus 3x. Minus 3x right there. Okay, so that goes on in the numerator as well as the denominator. Okay, so now we can simplify. That becomes e to the minus 7x in both the numerator and the denominator. Okay, so we have that. Okay, so was this a good idea? We are letting x go to plus infinity. It's getting, it's becoming bigger and bigger. And, ooh, e to the minus 7x. We did not see that. We saw e to the 3x and e to the minus 4x. But you are intelligent people, and the coefficient of x is negative. Okay? So we said that when the coefficient is negative, you have a decreasing function. Okay? So therefore, as x goes to infinity, e to the minus 7x goes to 0. Okay? So that goes to 0 and this goes to 0. And we are left with simply, let me do that on the next line. Look better that way. So we are left with simply 10 over 20, which is also known as 1/2, of course. Okay, so that's great. We made the right choice in multiplying and dividing by e to the 1 over e to the 3x, because the resulting exponential function goes to 0 as x goes to plus infinity. Which means that for minus infinity, we should probably multiply and divide by the other exponential function. Okay, so this time, multiply and divide by 1 over e to the minus 4x. Aha! Okay, let's try that. Okay, get back over there. Oh, I know why, because we're reaching the end of that display. Okay, so what have we got here? So this time, the e to the minus 4x's cancel. So let's put that here. What's going to happen? This becomes 1, and that becomes 1. Okay, but we have e to the 3x divided by e to the minus 4x. E to the 3x divided by e to the minus 4x. Okay, let me try to see. Whoops, no. I'm going to have to make it a little bit smaller. Hang on a second. Now it's easier if I just made a separate display here. Okay. So we cancel the e to the minus 4x's, but we have e to the 3x over e to the minus 4x, which is both in the numerator and the denominator. Okay? So again, we have our rules for e to the u over e to the v. We subtract. So we get e to the 3x minus 4x. So that is going to be e to the 3x plus 4x. Okay? So that's going to happen in both the numerator and in the denominator. All right, and now we simplify. That is, oh, that's what was going on. I'm missing equal signs. That's why. Okay. So we have, copy this now. We have e to the 7x over here and e to the 7x down here. Okay, so remember before it was e to the negative 7x, okay? But since we are multiplying and dividing by the other exponential function, the exponent is the negative, okay? So instead of minus 7x, we get plus 7x, okay? But this is the right thing because e to the 7x, this is now going to approach 0 as x approaches negative infinity, okay? So our limit is simply going to be 3 over negative 12. And of course, that simplifies to negative 1/4. Ooh, different. Okay, so we get one horizontal asymptote as we go to negative infinity. We get minus 1/4. And as we go to plus infinity, let's scoot back here, we get a different horizontal asymptote. We get 1/2. That did not happen to our rational function where we had quadratic over quadratic. And in fact, that does not happen to rational functions at all. It does happen for these kinds of exponential functions. Okay, our last question. We want to know, do you have a vertical asymptote and where? Okay, we're not going to ask what's the limit as you approach from the right or from the left. Just, do you have a vertical asymptote? Okay, but here's our problem. And what did we see for our last example? To get a vertical asymptote, you need to be dividing by 0. Okay, so can the denominator, 20e to the 3x minus 12e to the minus 4x, can that be equal to 0? For what value of x? Value or values of x? So remember, before we had two values where the denominator was 0. Okay, so this is great. This gives us an opportunity to solve an equation involving exponential functions. Okay, so what do we want? We want that to be 0, so we'll move the minus 12x to the other side. We get equals plus 12 e to the minus 4x. Did I say x? E to the minus 4x. Okay, so that's good. However, we have two exponential functions. So what do you say we isolate the x's? We put the x's together. We get e to the 3x divided by e to the minus 4x. But on the right side, we will have constants divided by 12 over 20. Which of course simplifies to 3 over 5. Right on? I believe so. Okay, but now on the left, oh, this happened before. We need the rules of exponents, so you get 3x plus 4x, minus minus. So you get e to the 7x equals 3/5. Okay, so that's great. How are we going to solve this equation? Well, you can think of it in two different ways which are equivalent to each other. You can take the ln of both sides, or you can think of this as a logarithmic equation instead of an exponential equation. I think it's easier if we just think of it as take the ln of both sides. So ln of e to the 7x equals ln of 3/5. All right, so now ln of e to the 7x, by cancellation property, that's just 7x, and we get ln of 3/5 on the right. So we have our final answer. X must be 1 over 7 ln of 3/5. Okay, so that is our exact vertical asymptote, 1 over 7 ln of 3/5. And that is approximately, oh great GeoGebra, oh no, Maple, oh great Maple. Ooh, it's minus 7.2 times 10 to the minus 2, so that's approximately negative 0.073. All right, so let's put that all together. That's our vertical asymptote, and our horizontal asymptotes are minus 1/4, and I believe it was plus 1/2. Yes, plus 1/2. Okay, let's go to GeoGebra. All right, so to save time, I input our function over there, and we do see a vertical asymptote. It almost looks like it's the y-axis, but of course we know it's not. Check it out. This graph is intersecting the y-axis. Okay, so there is a y-intercept. If you plug in 0, both of these are going to be 1. All 4 of them are going to be 1. So we get 13 divided by 8. So that's a little over 1. We get a y-intercept something here, something we didn't realize was there. Okay, we have 2 horizontal asymptotes. We said that to the right, it is 1/2. Ooh, there it is. Okay, so as we go to the right, you can barely tell the function, distinguish it from its horizontal asymptote, but we get a different horizontal asymptote on the left. Y equals negative 1/4. Oops, and oops, typo 1/4. There you go. Like that didn't look right. Okay, so there it is. That is our horizontal asymptote minus 1/4 as we move to the left. Okay, so the correct vertical asymptote is approximately x equals negative 0.73. Ooh, there it is. Okay, so that is the true vertical asymptote. Okay, so as you can see, the function is staying only to one side of that vertical asymptote. All right, well, that is our video for today. I hope you enjoyed it. I hope you found it useful. So until next time, I hope you enjoy the rest of your day. All right, bye.